Hello everyone, this is Nirali Patel from New Idea Institute of Engineering and Technology. In today's lecture, we are going to continue with mean deviation. So let's get started. So for the individual observation, mean deviation is given by mean deviation is equals to sigma mod x minus a upon small n, where small n is the number of observation and a could be mean, median or mode. Suppose if you find the mean deviation about mean, so in that case the value of A is mean. Suppose if you are finding the mean deviation about median, so in that case the value of A is median. Suppose if you are finding the mean deviation about mode, so in that case the value of A is nothing but the value of mode. Now the mean deviation for simple frequency distribution is given by sigma f mod x minus A upon sigma f, or we can write the capital N. Similarly, with the group frequency distribution also, the mean deviation is sigma f into mod x minus A upon sigma f. For group frequency distribution, to find out the value of x, we have to take the midpoint of the class interval. So x is nothing but the class mark for the group frequency distribution. Now, coefficient of mean deviation, so that is given as mean deviation divided by A into 100. So that is the coefficient of mean deviation formula. Now let's see some examples. So the first example is that find the mean deviation from mean and median. So to find out the mean deviation about mean, first we have to find out the value of x bar. So that is nothing but 40 plus 28 plus 68 plus 57 plus 50 plus 20 plus 36 plus 74 plus 54 plus 32 plus 8 all over. Now the number of observation are 3, 6, 9 and 11. So the x bar is equals to 42.45. Now the mean deviation about mean is equals to sigma x minus A upon n. So that is nothing but 40 minus 42.45 plus 28 minus 42.45 plus absolute value of 68 minus 42.45. Likewise, 57 minus 42.5, 57 minus 42.45 plus 50 minus 42.45 plus mod 20 minus 42.45 plus mod 36 minus 42.5 plus mod 74 minus 42.5 plus mod 54 minus 42.5 45 over here also, that is 42.45 and plus mod 32 minus 42.45 plus mod 8 minus 42.45 whole over divided by 11. So the mean deviation about mean is equals to 60.49. So this way we can find the mean deviation about mean. Now similarly we can find the mean deviation about median. So for the mean deviation about median, first we have to find the median. And now to find out the median, first we have to arrange the data. So that is the 8, 20, 28, then 32, then 36, 40, then 54 and 57, and before that one is 50 also. So 50, then 68 and 74. Number of observations are 11. Okay. Now median is equals to 11 plus 1 whole divided by 2th term, because the number of observations are odd. So that is nothing but the 6th term. So first, second, third, fourth, fifth and 6th term. So median is nothing but the 6th term. So that is equals to 40. Now find out the mean deviation about median. So we are just going to use the same formula that we have discussed for the previous mean deviation about the mean, that is sigma x minus a upon small n. So over here, the value of a is now 40 because we are finding the mean deviation about the median. So that is equals to 40 minus 40 plus more 28 minus 40 plus more 68 minus 40 plus more 57 minus 40 plus more 50 minus 40 plus more 20 minus 40 plus more 36 minus 40 plus more 74 minus 40 plus more 54 minus 40 plus more 32 minus 40 plus more 8 minus 40 whole over 11. So the answer for this is equals to 16.27. So now suppose if you want to find out the mean coefficient of mean deviation about median, so that is nothing but the 60.27 divided by 40 into 100. So that is your answer. Now let's find out the mean deviation about mode. So here I have taken the example for the simple frequency distribution. So first we have to find the mode because the formula for the mean deviation about the mode is equals to sigma f x minus a upon capital N. That is nothing but sigma f, which is equals to 50. Now, in order to find the mean deviation about mode, first we have to find out the value of mode. So mode is nothing but the value of x with the higher frequency. So mode is 175 because the highest frequency that is of 175. Now first we have to find the mode x minus a, that is nothing but the mode x minus 175. So that is equals to 30, 20, 10, 0, 10 and 20. Then f into x minus mode x minus a. So that is 120, 120, 100, 0, 90 and 60. So sigma f into mode x minus a is equals to 490. So now we have to just put the value over here, 490 divided by 50. So that is equals to 9.8. Now suppose if you are given with the group frequency distribution, so you know that you have to find out the x and then you can apply the same approach. Now let's discuss about the quartile deviation. So the quartile deviation is nothing but that is equals to Q3 minus Q1 divided by 2. That we have already discussed in the previous lectures as well. But now here we are finding the quartile deviation for the individual observation. So in order to find out the Q1 and Q3, let's discuss how we can find the Q1 and Q3. So Q1 and Q3 is nothing but in general we can write Qk is equals to K into n plus 1 divided by 4th term, where K is equals to 1, 2, 3. Now here we are taking this example 5, 8, 15, 18, 20, 25, 30 and 40. So in order to find out the value of Q1 and Q3, data must be arranged in either ascending order or in descending order. So here the data is already in the ascending order. So let's find out the value of Q1, that is nothing but n plus 1 divided by 4th observation or term. So over here n is nothing but the number of observations. You can also write the small n as well. So there is nothing but 1, 2, 3, 4, 5, 6, 7, 8. 8 plus 1 divided by 4, that is the 9 by 4th term. So that is equals to 2.25th term. So we can write 2.25th term as second term plus 0.25 into third term minus second term. So the answer for that is nothing, second term is 8 plus 0.25 into 15 minus 8. So this is equals to 9.75. Similarly, you can find the value of Q3, that is equals to 3 into n plus 1. So that is nothing but the 8 plus 1, 9 divided by 4th term. So that is equals to 6.75th term. So that is equals to 6th term plus 0.75 into 7th term minus 6th term. So the answer is nothing. 1, 2, 3, 4, 5, 6, that is the 25 plus 0.75 into 30 minus 25. So the answer for that is 28.75. Now we have to just put the value over here. So 28.75 minus 9.75 whole over 2. So the answer is equal to 9.5. So this is the quadratic deviation. Now moving to the next example. So it is given that x and f, the x is 2, 5, 9, 10, 15 and the f is 1, 2, 2, 5 and 3. So in order to find out the quadratic deviation, so that is nothing but q3 minus q1 divided by 2 and q3 is equals to 3 n plus 1 divided by 4th term where n is equals to sigma f which is equals to 30. So that is nothing but n is equals to 30. Now, so Q3 is equals to 3 into n plus 1 divided by 4th term. So that is nothing but 3 into 14 divided by 4th term. So we can write that is equals to 10.5th term. So that is nothing but 10th term plus 0.5 into 11th term minus 10th term. Now, how we can decide the 10th term and the 11th term? So for that, we require the cumulative frequency. So that is 1, 3, 3 plus 2, 5, 5 plus 5, 10, 10 plus 3, 30. So 11th term, that means the 15 and 10th term, that means the 10. So 10 plus 0.5 into 15 minus 10. So that is equals to 12.5. Similarly, we can find the Q1. So for Q1, n plus 1 divided by 4th term. That is equals to 3.5th term equal to 3rd term plus 0.5 into 4th term minus 3rd term. Now over here the 4th term, that means 9 and 3rd term, that means 5. So whenever you put the 3rd term 5 and the 4th term is 9, so you will get 7. So Q3 is 12.5 minus 7, that is your Q1 divided by 2. So you will get quadratic deviation that is equals to 2.75. Now moving to the next example, that is for the group frequency distribution. So over here the class is given and quadratic deviation is Q3 minus Q1 divided by 2. So for Q3, let's first find out for Q1. So Q1 is nothing but that is equals to L plus H by F into N by 4 minus C, where L is the lower limit of Q1 class, H is the class width of the Q1 class, F is the frequency of Q1 class, and C is the frequency of preceding class of the Q1 class. Now, what is the Q1 class? So you can decide the Q1 class from the N by 4. This we have already discussed in the median as well. In median, we have decided the median class from the N by 2. Over here, we are deciding the value of the Q1 class from the N by 4. So for that, we require the cumulative frequency. So that is 3 plus 9, that is equals to 12. 12 plus 12, 24, 35, 40, and 46. So sigma f is equals to 46 and n by 4 is equals to 11.5. Similarly, you will require the 3n by 4 to decide the Q3 class. So just I'm calculating the 3n by 4. So that is equals to 34.5. Now let's first find out the value of Q1. So that is the nothing but Q1 class decided from the n by 4, that is 11.5. So the value that CF, that is just greater than 11.5, is this 12. So this is your Q1 class. Now the value of L is 10, the value of H is 10, the value of F is 9, n by 4 is 11.5 and the value of c is 3. So Q1 is equals to 19.44. Similarly, you can find out the value of Q3, that is the L plus H by F 3n by 4 minus C. So that is equals to, so 3n by 4, from this we can decide the value, the class Q3. Okay, so 34.5. So this is your Q3 class. The value of L is 30, the value of H is 10, the value of F is 11, the value of 3n by 4 is 34.5, and the value of C is 24. So whenever you solve this equation, you will get Q3 is equals to 39.54. Now you have to just put the value of Q3 and Q1 over here. So 39.54 minus 19.44 divided by 2. So that is equals to 10.05. Now suppose if you want to find out the coefficient of quartile deviation, so that is given by Q3 minus Q1 upon Q3 plus Q1. So this is the formula for finding the coefficient of the quartile deviation into 100. So this is the formula for finding out the coefficient of quartile deviation. Now, moving to the next topic, that is the standard deviation. So we have already discussed about the standard deviation in the previous lectures. Now let's discuss about the standard deviation for individual observation, discrete series, and for the continuous series. So for individual observation, standard deviation is given by under root of sigma x squared divided by n minus sigma x whole square divided by n. And the another method is standard deviation, that is assumed mean method. So that is sigma under root of sigma d squared divided by n minus sigma d n whole square n. And over here also sigma x divided by n whole square. So that is nothing but the x bar square. Now d is equal to nothing but x minus a, where a is the assumed mean. So over here, I'm following the direct method. So for that, the x is given, that is the 3, 4, 6, 7, 9, and 15. And we can write the x bar is equal to 9, 16, 36, 49, 81, and 2 to 5. So we can find the value of sigma x and sigma x square. So sigma x is equals to 44 and sigma x square is equals to 416. So now we have to just put the value over here in this equation. So that I'm writing over here, standard deviation is equals to, that is also denoted with sigma. So that is equals to sigma x squared, that is the 416, divided by n, that is the number of observation, that is the 6, minus sigma x, that is the 44, divided by 6 whole square. The answer for standard deviation is equals to 3.94. Similarly, you can solve the same example through this formula as well. Now, moving to the next example, that is for simple frequency distribution. So, standard deviation for simple frequency distribution, or you can say the discrete series, is given by this formula, that is under root of sigma fx square divided by n minus sigma fx divided by n whole square, or you can make use of the assumed mean method, that is the sigma fd square divided by n minus sigma fd whole divided by n whole square, where d is equal to x minus a, and where a is equal to nothing but assumed mean. And over here, capital N is sigma f. So now over here, I'm using this direct method formula to solve this example. So f into x, there is 35, 40, 90, 60, and 125. And f into x square, that is equals to 175, 400, 1350, 1200, and 3125. So here we have to just multiply fx into the x. Now we require the sigma fx. So sigma fx is equals to 350. You also require the capital N, that is the sigma f. So that is equals to 25, and sigma fx square. So that is equals to 6250. Now we have to just put the value in this equation. So sigma fx square, so standard deviation is equals to sigma fx square, that is 6250 divided by 25 minus sigma fx, that is 350 divided by 25 whole square. So the answer is nothing but 7.34. Now if you are using the same this formula, then you will get the same answer, that is the 7.34. Here you have to take the value of d, that is the x minus a, and you can take x minus a, so you can take a is 15, so that is nothing but 5 minus 15, that is minus 10, 10 minus 15, that is minus 5, 0, 5 and 10. So you will get d is 0. Similarly, you can find the f into d from f into d and f into d square from the fd into d. So this way you can get the fd and fd square. You can calculate the sigma of that and you can just put the value of that in this equation and you will get the same answer, 7.34. Now the next is for the group frequency distribution. So for group frequency distribution, we can calculate sigma, that is the standard deviation. So that is equals to nothing but sigma fx square divided by n minus sigma fx whole divided by n whole square. So this is the same formula that we have discussed in the previous topic, simple frequency distribution. Over here we can find out the value of x by taking the midpoint. The another formula is standard deviation is equals to sigma fd square divided by n minus sigma fd divided by n whole square into h. And over here, d is equals to x minus a divided by h, where h is the width of the class interval and a is the assumed mean. So let's discuss this example through the step deviation method. So let's understand this example. So over here, the standard deviation sigma is equals to under root of sigma fd square divided by n minus sigma fd whole divided by n whole square into h. Now the value of h is 30 because 30 minus 0, 30, 60 minus 30 is 30. So the value of h is nothing but the 30. Now let's find out the d. So that is the x minus a by h. So in order to find out that, first we have to find the x. So x is nothing but the midpoint of this. So that is 15, 45, 75, 105, 135, 165 and 195. Now d is equals to x minus a divided by h. So over here as a value of a we can take the 105. So 50 minus 105, that is the 90 divided by 30. So that is the minus 3, minus 2, minus 1, 0, 3, sorry, 1, 2 and 3. So now f into d, that is minus 27, minus 34, minus 43, 0, 81, 88 and 72. And similarly fd square, so that is the 81, 68, 43, 0, 81, 176 and 216. Now sigma fd square, so summation of this all value is equals to 665. Sigma fd is equals to 137 and sigma f is 300. So standard deviation is equals to sigma fd square, that is 665 divided by 300 minus sigma fd, that is 137 divided by n, that is 300 into a whole square into 30. So the answer for the standard deviation is equals to 42.5. So this is the answer for the standard deviation. Now moving to the next topic, that is the variance and coefficient of variance. So variance is nothing but, as we have discussed, that is the square of the standard deviation. So that is denoted by sigma square. And coefficient of variance, so that is given by sigma upon x bar into 100. So this is used to measure or compare two or more than two series. Suppose if you want to find out that there are three teams A, B, C, and which team is more consistent from the data, so you can find out through the coefficient of variance. If the coefficient of variance is higher than the less consistent in the series, and the coefficient of variance, that is denoted by CV, is lower, so series is more consistent. That means less variability. And value of CV is higher, then the series is less consistent. That means higher variability. So this way, we can make use of this coefficient of variance two and more than two groups. So this is all about the coefficient of variance and variance. So this is all about the measure of central tendency and measure of dispersion for group and ungrouped data. We have already discussed about the moments, skewness, and kurtosis. So the same thing we can apply over here for the ungrouped and grouped data. So this is all about measure of statistics. Thank you.